Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. This is the TommyKnocker assembly video. The Kickstarter is linked below. This set allows for you to program secret knocks and control AC devices, other circuits, or an electromagnetic lock using secret knocks. So, using this video, we'll be putting together one piece by piece in case you've pledged towards a DIY kit version of this set. So here are the components. Custom PCB, 5-volt relay, 7805 5-volt regulator, 5mm power jack, piezo cable, 2-wire, piezo sensor, an NPN transistor, 3 100 microfarad ceramic capacitors, a 10k ohm resistor, a 91k ohm resistor, 2 470 ohm resistors, 5 jumpers, an one N4001 diode, programmed 18-pin microcontroller, 18-pin socket, programmed 8-pin microcontroller, 8-pin socket, 2 100 microfarad electrolytic capacitors, a green LED, blue LED, red LED, 2-pin terminal block, 3-pin terminal block, 2 2-pin headers, a 6-pin header, and a 10-pin header. Now, first things first, we're going to connect all of the resistors. The resistors have no polarity, so as long as they're populated in the right spot, you won't have any problem. It might be a little bit difficult for you to see, but when you have the printed circuit board in front of you, this will make a bit more sense. So first thing you want to do is segregate your resistors. Again, we've got 2 470 ohm resistors right here, a 10k ohm resistor, and a 91k ohm resistor. Your 10k ohm resistor goes in the 10k slot right here. Again, no polarity with resistors. Your first 470 ohm resistor goes in this slot right here, labeled 470R. Your other 470 ohm resistor goes in the bottom slot right here, labeled 470R, and your 91k ohm resistor goes in the 800k slot. Now, 800k was the original value I've used. Now I'm going, for these specific piezo sensors, I'm going to be using a 91k ohm resistor. So make sure they're flush to the board, good solder joints, no shorts to any other pads or vias. And what I'm going to do is I'm going to solder those into place. I'm going to show you what the board looks like, and then we're going to solder in our capacitors. What you'll notice about the two 100 microfarad electrolytic capacitors is that there's a long lead and a short lead. That's because these capacitors are they have a polarity. They're polarized. So when you're soldering those into place, you have to make absolutely certain that the positive, which is the long lead, is placed in the correct hole, and that the shorter lead, the negative, is connected into the proper hole, or else you might pop those capacitors and ruin the board. So we'll get to those in a minute. The ceramic capacitors, their lead sizes are equal. They have no polarity, so it doesn't matter which way you solder them into place as long as they go in the right slots. So what we're going to do is we're going to solder 2 of them into C4 and C5, labeled C4 0.1U and C5 0.1U, and then lastly C2 right here, labeled C2 0.1U. Solder those into place. They won't go flush down into the board, but they'll go pretty far. Just jiggle them down into place. They solder in nicely. Make sure there are no shorts after you've soldered them into place. And your 2 electrolytic capacitors go right here in C3 and C1. They're labeled C3 100U and C1 100U. Now again, it might be a bit difficult for you to see. And these 2 pins, there's two holes side by side, and they're very close together. So you want to make sure that when you solder them into place, they do not short together, because it's easy for you to short them together. So pay close attention here. In the case of C3, the bottom hole is negative, the top hole is positive. So long lead from this perspective into the top hole, short lead in the bottom from this perspective. You turn that around, you power it up, poof. Your house is going to smell, because blown capacitors smell horrible, and you could very well damage the printed circuit board, and you'll need to replace the capacitor. So again, long lead top hole, short lead bottom hole. In the case of C1, long lead in the right hole, short lead in the left hole. Very, very careful. Long lead in the right. There's a little plus sign right below the right hole here. In the case of C1, there's a tiny plus sign in the top hole. So look for that when you're soldering these into place. Now make sure that there are no shorts. In the case of C1, there's a little via nearby. Make sure that you don't short the right hole to that specific via. So Be very careful, solder them into place, make sure there are no shorts, use a magnifying glass if you can, and next we're going to place both our diode and our NPN transistor. Here's a much better view. The NPN transistor goes in the T1 slot, and the diode goes in the slot right above it. And what you'll notice about the diode slot is that there's a white line on the right, and you'll notice on the diode there's a white line to one side. You want to make sure that the side of the diode with the white line faces the right side of the board, and that the side that's complete black is on the left side. If you turn that around, every time the relay turns on, you're going to get a complete system reset. Nothing's going to happen. The relay will not work, and it will reset the system. So white stripe facing the white stripe on the footprint, black side of the diode facing the left. So black lead in this hole, white lead this hole. As for the transistor, the front has writing on it. You can't see it. I can't even see it. It's very small. You need some good light and magnifying glass to see it. But what you'll notice is there's on the back it teeters because the back is rounded and the front is flat. On the T1 footprint, there's a flat side facing the bottom of the board and the curved side facing the back of the board. Make sure that from a bird's eye view, when you place the NPN transistor, that the flat side with the writing on it is facing the bottom of the board and the curved side is facing the back of the board. Because obviously it only teeters on one side. If I turn this around, hopefully it's not going out of focus, I'm sorry if it is, it won't teeter anymore because the flat side is facing the ground. So solder those into place. Make sure that you have a fine soldering iron to do this because the T1 holes are the transistor holes are close to each other to make sure that there are no shorts. And then next what we're going to do is we're going to solder in our LEDs. Okay, for the LEDs, you'll notice that they all have a long lead and a short lead. Now I've set these LEDs up very specifically so that you're seeing them with the long lead on the left and the short lead on the right. And they are going into these three LED slots. They're labeled HT for hit, yes for yes, and no for no. The colors go in this order. Green is HT for hit, blue is yes, and red is no. Now, you want to make sure that you place these in the right orientation or else the LEDs won't light up. You're not going to hurt anything, but you need these LED indicators to use this set. So, for the green LED in HT, long lead in the left hole, short lead in the right hole. Short leads all go in the right holes here, on the sides with the writing. So HT is short lead, yes side is short lead, no is short lead. So green, long lead in the left, short lead in the right. Red and no, long lead in the left, short lead in the right. Yes LED, blue, long lead in the left, short lead on the right. All long leads on the left, all short leads on the right. I just want to be very specific because it's not fun removing these LEDs once you've soldered them into place. So what I like to do is I like to place all of the LEDs on the board without soldering. Then I use one finger to hold them down. And on the other side of the board, I use my right hand and I tip the end of my soldering iron with a little bit of solder, and I dab that solder on one hole so it holds it into place. Then you can turn the board around and make sure that they're all being held into place and that they're all flat onto the board. Then I can turn it around, solder all of the other holes, and then retouch up the solder on the holes that I just dabbed with solder to hold them into place. That's how I like to do it. You can solder one by one, however you like it. I find it's a bit faster to put them all into place, hold it with my one finger, and dab solder onto one hole of each LED just to hold it in place. But you do it however you want. Whatever makes you more comfortable, whatever you have. Everyone has their own soldering methods. So, after we solder those into place, we are going to solder in our headers. This is a relatively easy step, but you have to make sure you do it right. So there's the 10-pin header, which goes right here, 6-pin header, which goes right here, and the two 2-pin headers that go side by side right there. Now, what I like to do, and I can't do this, I can't really show you while I've got the camera down, but what I like to do is I like to use my nail, hold the header down in place with one hand, turn it around, and dab one solder pin either on this end or on this end to hold it in place. I turn it back around and make sure that it's sitting at 90 degrees, and then I turn it back around and solder it. So ideally you place it with the long leads facing up. That's very important. I'm just going to try to give you an idea of how I do this without going out of focus. Holding it with one finger, turning it around, tinning my soldering iron and just dabbing it on one end to make sure that it's in place. And once you're sure that it's in place, turn it around, make sure that it's sitting at 90 degrees, then solder the rest of them. And then once you're done soldering the rest of them, refinish that original pin that you added a tin solder to. Make sure there are no shorts. Now follow those instructions for all 4 of these headers, making sure that the long pins are facing up. That's, again, very, very important. Once you've soldered those into place, we will solder in our sockets. Okay, please pay close attention here. On the footprint there are 2 areas for our sockets, here and here. What you'll notice is on the right side from this perspective, the 18-pin socket, there's a little indent on the right above IC1. And you'll notice that on the socket there is a little tiny notch on one side. You want to make sure that from a bird's eye view, you place the notch of the notch side of the chip of this 16-pin 18-pin socket to the right to face with that notch right there. This is all for orientation, because if you don't have that, you might place your chip in backwards and that'll fry the chip. So for the 8-pin socket, you'll notice that the notch faces the right. Make sure that when you place from a bird's eye view, that notch faces the right. Again, what I like to do is place it in, hold it down with one finger, turn it around, tin one pin, turn it around, make sure that it's sitting flat on the board, and then solder the rest of the pins. Now the pins are relatively close together, so you want to make sure that after you've soldered everything, that there are no shorts to either adjacent pins or vias. There aren't very many vias in the way here. There's one right here. Just be careful not to short to it. But it's it's a simple step. Just take your time and make sure that you sit the sockets in the right direction. So after we solder the sockets in, we will solder in our 2 terminal blocks and our DC power jack. This is an easier step. The DC power jack has 3 pins and it sits in this slot right here. It only fits in one way, with the hole facing this side of the board. It only fits in one way. Make sure that it's flush when you solder it. Don't apply too much heat all at once. Spread it out a little bit when you're filling the gaps of the holes. I only say that because you don't want to melt the plastic. If you melt the plastic, it might not work very well. And this rarely ever happens. But if you've got your soldering iron set to like extremely high wattage and you're just going nuts on it, what I like to do is add a little bit of solder here from the bottom of the board, then here, then here, then here, then here, then here, until the gaps are filled. And they don't need to be completely filled, as long as there's a connection. Now the terminal blocks, very simple. There's a 2-pin terminal block and a 3-pin terminal block. And they have a side with the terminals, which have to face the bottom of the board. They have to face outside of the board, because the other side is just plastic, and you'll never be able to wire in your connections from this side. So make sure that that the terminals are facing out. So I'm going to solder those into place. Then what we're going to do is we are going to solder in our 5-volt relay and our 7805, and then we're on easy street because the last 2 steps are very simple. So the relay has 5 pins. The slot has 5 pins. Again, this only fits in one way. Make sure that when you place it, that it sits nicely in the holes. It's flat down. Hold it with one hand. Touch some solder to one pin to hold it in place. Make sure that it's still sitting flat when upside down. Solder the rest of the pins. And make sure that each pin gets a fair amount of solder. Now, the 7805 is, it's very simple. It's a 3-pin. This is the front. That's the back. It goes in this slot. The back of the footprint has a little white stripe on it. So you want to solder it in with the front facing the inside of the board and the back facing the outside of the board. Very important. You turn this around, this is not the way you want to solder it, with the back facing the inside of the board. Solder it that way and your circuit will not work. So place them in. I can't do this without moving the camera. Solder the pins, make sure there are no shorts, and make absolutely sure that the front side with the writing on the black front side is facing the inside of the board. Once you have that soldered into place, we're then going to place our chips into the sockets, and then we're going to solder together our piezo sensor. Alright, remember the conversation we had about notches? Again, it might be very difficult for you to see here, but I've turned my 18-pin chip to the right because the notch is facing the right, just like our notch on the socket. In the case of the 8-pin, I've got my notch facing the left. There's a little notch that you might be able to see, might not be able to see, because we've soldered in our socket with the notch facing the left according to the footprint. So I'm going to zoom out a little bit. And what I like to do for this, sorry that's my phone, is I like to try to line up the bottom pins first, make sure they're lightly seated, and then I like to just gently massage the top pins so that they're actually in the holes. Then it should pop into place. If you have any doubts or something does not feel right, take the chip out and try it again. Same goes for the, some people have different methods of doing this. This is just mine. So bottom pins first, massage the top pins into the top holes, and then pop. Double check to make sure there are no bent leads, that it's sitting nicely. And that is the main board. So now we have to just solder together our piezo sensor and then solder the piezo sensor and cable to the main board. What I've done here is I've removed about a millimeter and a half of insulation on both ends of the red wire and the black wire, all while making sure that it's still curled together. And I've added some, I've tinned the exposed copper wire, and I've tinned that just so it makes an easier bond when I solder to the piezo sensor. So first things first, what I'm going to do is I'm going to remove this from the equation. I'm going to center this, and I'm hoping that my camera doesn't go out of focus here, but the idea is to put a little bit of solder on the outside copper, not going nuts, just a little bit, and making sure that it doesn't spill all the way over to this edge, and then another splotch right in the middle. So I'm going to try to do this on camera so you can watch, and there's a little bit here. And I'm going to add another splotch to the middle. Now what I'm going to do is I'm going to tin my soldering iron. Connect that. You want a bit of a better solder joint, but for the sake of the video, I just don't want to have to stop it and try it again. There we have it. There's two pads here, P plus on the left and P minus on the right. What I like to do is add a little bit of solder to both. P plus is red. I'll tin my soldering iron again. And you don't need to put it in the hole. Do it as you like. I just soldered it on top. It's in. Tin my soldering iron again. I'm looking through the lens of the camera, so it's a bit difficult for me to see this, but there we go. So that's it. There you have it. When you connect this to a surface that you want to knock on, you just add a little bit of hot glue on the top so that it's flat to the surface, and that's it. And one thing to note about piezo sensors is humidity is the worst enemy. Don't expose them to humidity. If you're going to have this against a permanent surface, encase it in either hot glue or epoxy so that it's not exposed to humidity. So we're going to use this exact board for the next video, which will be the video manual. Thanks for watching.